We need energy to power our world, our cars, our homes, our everything. But fossil fuels like coal and oil are polluting our planet. They're like a dirty furnace spewing harmful gases into the air we breathe. We need a cleaner solution, a better way. Nuclear energy is a powerful alternative. It's like a super-efficient battery capable of generating massive amounts of electricity without emitting greenhouse gases. Imagine a world with cleaner air, a healthier environment. That's the promise of nuclear energy. However, the mention of nuclear energy often evokes fear and apprehension. Images of past incidents like Chernobyl loom large in people's minds. But it's important to remember that technology has advanced significantly since then. Just like any powerful tool, nuclear energy requires responsible handling and continuous improvement. By understanding the science, addressing safety concerns, and promoting transparency, we can unlock the immense potential of nuclear power for a brighter future. So how does nuclear energy work? It all starts with a process called nuclear fission. Imagine a group of friends all huddled together. They represent a uranium atom, the fuel for nuclear power. Now imagine someone throws a bouncy ball or a neutron at this group. Boom! The group splits apart, releasing a burst of energy. That's fission. It's like splitting a tiny grain of sand and releasing a tremendous amount of power. But here's the really cool part. When the atom splits, it releases more neutrons, like little sparks. These neutrons can then go on to hit other uranium atoms, creating a chain reaction. This chain reaction is what allows us to generate a steady and controlled release of energy, which we can then use to produce electricity. It's like a perfectly choreographed dance of atoms releasing energy with every step. To harness this energy, we use nuclear reactors. Think of them as special ovens that control the nuclear chain reaction. Inside the reactor, uranium fuel rods are carefully arranged to sustain a continuous chain reaction. Surrounding the fuel rods is a moderator, a substance that helps slow down the neutrons. It's like a speed bump, ensuring the neutrons are traveling at just the right speed to trigger fission. To prevent the reaction from getting out of control, we use control rods. These rods, made of materials like boron, absorb neutrons and can be inserted or withdrawn to regulate the rate of fission. It's like having a dimmer switch for a really powerful light bulb. The heat generated by fission is used to produce steam, which drives turbines to generate electricity. It's the same principle used in coal-fired power plants, except the heat source is much cleaner and more efficient. Section 4. Safety and public perception. Safety is paramount in nuclear energy. Nuclear power plants are designed with multiple layers of safety systems to prevent accidents and contain any potential releases of radiation. Think of it like a Russian nesting doll, with each layer providing an additional barrier of protection. The reactor core is housed within a strong containment structure designed to withstand extreme events. Furthermore, stringent regulations and rigorous safety protocols are in place to ensure the responsible operation of nuclear facilities. The lessons learned from past incidents have led to significant advancements in reactor design and safety culture. It's understandable that people have concerns about nuclear energy, but by promoting transparency, providing accurate information, and engaging in open dialogue, we can address these concerns and build trust in this vital technology. Section 5. The future of nuclear power. Nuclear energy has the potential to play a significant role in a sustainable energy future. Researchers are constantly working on new reactor designs that are even safer, more efficient, and produce less waste. Imagine nuclear power plants that are small, modular, and can be deployed in remote areas, providing clean energy to communities around the world. That's the future we're working towards. But there's so much more to explore. From the intricacies of different reactor types to the compelling story of the Chernobyl disaster, the world of nuclear energy is full of fascinating details. Speaking of Chernobyl, stay tuned for our upcoming series where we'll delve deep into the events of that fateful night, exploring the science, the human impact, and the lessons learned.